9, 10 classes. So today we are going to discuss about atomic mass, molecular mass, then the concept of mole, which has evolved from Avogadro's hypothesis. We'll try to recollect. Because why I'm telling you? Because in future, when you will be appearing your entrance exam, this chapter is very, very useful. Now, atomic mass. So what is atomic mass? I think most of you know. Okay, so let us have a little bit story about it. See, atomic mass is the mass of one atom. But how to take weight? Whenever you take weight, we require a reference. You go to market, you want to buy any grocery item, anything that you want. So if you want it in mass or weight, so in that case, what they will put one weighing stone on one of the pen, and the other side they will put on. Okay? So now, so if they have put 1 kg, and the substance in the other side is, you find it balances, then you can, that you are sure that you have bought 1 kg. If it is 500 gram, then 500. So we also have to now measure the weight of atom, which is very, very tiny. So if it is very tiny, your measuring substance also, substance mass also should be very, very less. So initially people thought that hydrogen is the smallest atom, and it also has the smallest mass. And they have considered that because hydrogen contains 1 proton and 1 electron, and we know the mass of the proton is 1, so they thought that hydrogen atom is 1. So initial definition was that what is atomic mass? That how many times an atom is heavier than 1 atom of hydrogen. Similarly, what is a molecular mass? We call it how many times a molecule is heavier than 1 atom of hydrogen. Because of that, because we are comparing the mass of the substance with the mass of 1 atom of hydrogen, so that is it is in relation with the hydrogen. So because of that, atomic mass, its precise name is relative atomic mass, because you always find with the help of a reference. So relative atomic mass, now we call it atomic mass. Relative molecular mass, we call it molecular mass. But thing was not that easy. Why? After the discovery of the 3 isotopes of hydrogen, hydrogen has 3 isotopes, you know it. The one is called protium, other one is called deuterium, and third one is called tritium. So protium has a mass of 1, deuterium has a mass of 2, and tritium has a mass of 3. So when you want to measure the weight against the hydrogen, you cannot separate this protium, deuterium, and tritium from the mixture. So in that case, you have to take an average mass of the hydrogen. Generally, you find that out of the 100 atom, almost 96 are protium. Then 2 to 3 atoms are deuterium, and 1 atom is tritium. So in that case, you have to find it. Suppose you want to find average mass, then what you will write? 96 into 1 plus 3 into 2 plus 1 into 3. So total mass is not 100 now. 96 plus 6 is 102. 102 plus 3 is 105. So what is the average mass? If you divide it by 100, you will find that it is more than 1. So accordingly, we find the mass of 1 atom of hydrogen is determined to be 1.008. So all the masses that we determine initially by considering the mass of one atom of hydrogen to be 1, we found all of them are wrong. Say if you have gone to market and if the person has is the businessman is dishonest from the that weighing stone, suppose he removes some of the substance from there, then you will see from the top is 1 kg, but actually it's not 1 kg. It may be 990 gram, or maybe if he is more dishonest, then it may happen that it is 900, 500, 950 gram. So for 1 kg, he is cheating you 50 gram. So many a time we say that shopkeeper is dishonest because he is giving us less weight. Okay. Now, so we find that we ourselves has proved that actual the average mass of hydrogen is 1.008. So in that case, that hydrogen scale was discarded. Then we thought, if I have to compare the mass of any element with something else, then this element should combine with that element. Otherwise, staying in Shillong, you cannot compare your height with another person who is there in Guwahati or far away. You have to be side by side. Then only you can decide who is taller and who is shorter. So we have found that one element is present in the periodic table which combines with almost all elements, and that is oxygen. So after that, another scale was being adopted. We call it oxygen scale. So how it is being defined? It is being defined that how much time an element is heavier than 1/16 part of oxygen, or 1/16 part by weight of one atom of oxygen. Why do you take 1/16? Where from? Because mass of oxygen one atom is 16. So 16 by 16 is 1. So if you compare anything against unity, it is easy for us to find out is my mass. So it has continued for some time. But again, the problem, because oxygen has also 3 isotopes. Oxygen 16, oxygen 17, and oxygen 18. So same problem was there, and their abundance is more. So we have discarded this one. So ultimately we went to a scale, and still it is being continued. We call it carbon 12 scale. So in that case, what you say, that atomic mass, how much time an atom of an element is heavier than 1/12 of mass of one carbon 12 isotope. Carbon 12 means the mass of that atom is 12 only. So 12 divided by 12 is 1. So this is the definition of atomic mass. And for molecular mass, instead of writing atom, we'll write molecule. So we write here molecule of a compound. Now, carbon also has 3 isotopes: carbon 12, carbon 13, and carbon 14. But we're a little bit safe, you know why? Out of 1,000 atom of carbon, only 1 atom of carbon is carbon 14. And carbon 14 is radioactive, generally is present in the upper part of the atmosphere. Carbon 13 abundance also is less. So in this case, the carbon mass of one atom of carbon, normal carbon that you find, is mostly because of carbon 12. Very less amount of other impurities are there. So we can go for a better approximation. Okay. So so we can write now here mass of one atom of the element divided by 1/12 part of mass of one atom of carbon 12 isotope. All right. Okay. Now, and you know this is being expressed in the form of atomic mass is being expressed in the form of AMU. So atomic mass is expressed as one. We said we write it AMU, or this case you simply call U. Now what is AMU? AMU is the mass of one atom of carbon 12. So 1 AMU is the mass of, okay, right, like this. So mass of one atom of carbon 12 isotope divided by 12. See here. So now it is being experimentally found that mass of, I don't know whether it's given in your book, one atom of carbon 12 isotope is equal to 1.99 into 10 to the power 24, not 24, 23 gram. And so, or what you can write? 1.99 into 10 to the power minus 26. So what is 1 m? 1.99 into 10 to the power minus 23 divided by 12, which comes to 1.66 into 10 to the power minus 24 gram, or 1.66 into 10 to the power minus 27 kg. Remember, this is the value of 1 m. Write down. So once you finish writing, you tell me. So now what is molecular mass? Molecular mass, or we also call it molar mass. Okay. So now we'll go for a principle we call Avogadro's law. Earlier used to call it hypothesis. Now we don't call it hypothesis. We call it law. Why? Hypotheses are the laws which are not being experimentally verified. Once you verify it and adopt it, then we call it law. Just like in our parliament, if the parliament is not in session and if there is an emergency in the country, then they bring forward a law, discussed in the cabinet and send it to the president for signature. So that is called ordinance. And it is valid up to 6 months. After that, once this is being discussed and adopted in the parliament, that it becomes a law. So now earlier it was called Avogadro's hypothesis. So, but anyway, this word is being removed and we call it Avogadro's law. So what is this Avogadro's law that you have studied in school? We say equal volume of all gases under same conditions of temperature and pressure contain same number of molecules. Please remember, Avogadro only first started the term molecules. Earlier, before that, molecules were not there. So I could understand you will not tell me anything, then I'll go on rubbing it. Later on, don't complete. Okay. So now, Avogadro has brought almost a revolution in chemistry. Okay. So from his law, he has brought out some proposals, and these are found to be exactly correct. So what are the things we learned from Avogadro's hypothesis? So applications of Avogadro's law. Okay. And I'm telling you, this is not given in your book. So let us try to know. Avogadro first introduced the concept of molecule. This is the greatest achievement. See, this word molecule was used in our country even before the birth of Christ, Jesus Christ. Okay? In Sanskrit, this is written like this, Anu. And the tinier particle than that of Anu was called Parmanu. But it's an irony. We have started with the first concept of Anu and Parmanu. But in science book, you'll find this, they are not being inherited or mentioned. We say the atom word has come from was being introduced by John Dalton. Then why they have not mentioned about, so that these days, a lot of resurgence of these Hindu ideologies is going on. I'm not a part of it. So everywhere we want to prove the supremacy of India. Science do not, frankly speaking, dear, science do not belong to any country, any religion, any linguistic group. Science is universal. But such resurgence is going on for last 7 or 8 years. We want to prove that we were the leader in everywhere, but actually we are flop. Many Vedic mathematics were there. You have to accept it. Why this was not being considered? Simple logic is that the example which was given for Anu and Parmanu, the example was wrong. These examples were wrong. So they even have mentioned that atom of water. Now all of us we know you cannot have atom of water. Water is a compound and is being made by the atoms of the elements. So somehow we do not accept our mistake because we have coined this word, but we do not know it was for what. Okay. So many may take it seriously. These days, very difficult to say the the science has been detached from our Indian education by the present government. Everywhere they are putting mythology. Huh? Imagine in Science Congress held in Bombay 5 years ago, our Prime Minister has mentioned that it is India who started the aeroplane. All the mythological ideas that is being written in our book, you also have read about these mythologies. He is saying that it is science. Okay. He has also mentioned that concept of plastic surgery was invented in India. Why? Because you have seen Lord Ganesh. Lord Ganesh does not have a head of human being, but the whole body is of human being. Okay? The head of the elephant is there. He told that that head of the elephant was being transplanted or plastic surgery was done on Ganesh. So if a prime minister of a country mentioned like that, what will happen to our Indian science? It is a very sad and irony. Okay. Second, he has mentioned about the term called atomicity. Here you have heard about atomicity. Atomicity is not a name, not the name of a city. Atomicity means how many atom has made one molecule of an element. See, you can have two types of molecule. Molecule of an element and molecule of a compound. See, if you have taken hydrogen, H2 is a molecule, all of you know it. H2 is a molecule, but H2 is a molecule of an element. But if you have taken H2O, H2 is a molecule of a compound. So what is atomicity? Atomicity is nothing but how many atoms have made a molecule of an element. So he has first brought this term, atomicity. So atomicity, it is the number of elements which makes the molecule of an element. So atomicity, we have noble gases, helium, neon, argon, krypton, xenon, and radon. How do you write? We write neon as Ne. That is, neon molecule consists of only one atom of neon. So atomicity of neon is 1. So when you go for the hydrogen, oxygen, fluorine, chlorine, bromine, iodine, we know in all these cases, 2 atoms have combined together to make the molecule of that element. Okay, so atomicity is 2. You will come across there the sulfur which you use, which is your pale yellow in color. This molecule is made by 8 sulfur atoms. So what is the atomicity of sulfur? Atomicity of sulfur is 8. So how to know? How will you determine atomicity? Atomicity is nothing but, I can find it. Atomicity is nothing but molecular mass of the element divided by molecular mass of the atom. Okay, that way you can find it. See, for sulfur, Atomicity of sulfur. Suppose we do not know. We find the molecular mass of the sulfur. Sulfur molecule is 256, but the atomic mass of sulfur is 32. So in that case, we find is equal to 8. So from there, we come to know it is S8. So the sulfur molecule consists of 8 sulfur atoms. Now, third. This is a very famous relationship. Relation between molecular mass and vapor density of a compound. Is a very famous relationship. Okay, so molecular mass is equal to 2 into vapor density. So you can find out the vapor density of oxygen. Okay, vapor density of oxygen. Let me write here V. Huh? See, molecular mass of oxygen is 32. So what will be its vapor density? 2. So it will be 16. And if you know the vapor density, you can measure it by an experiment. Suppose you have found an unknown molecule which exists in vapor state, is molecular mass you do not know. But experimentally you can measure the vapor density. So when you have measured the vapor density, you multiply it by 2. This is the molecular mass of the compound that you have prepared. Right.
Finished, sir.
Excuse me, sir. Sir?
Huh? Okay. Then the wonderful part about the thing that he has done, who has changed the face of chemistry, is the concept of mole. Concept of mole. What is his definition then, mole? I think you know it. It is the amount of substance which contains as many particles. Particles may be atom, it may be molecule, it may be ion. Yes, 12 gram of carbon 12 isotope. Okay. So how many it will have? See, 12 gram of carbon 12 isotope has 6.023 into 10 to the power 23 number of carbon atoms. Okay, you'll find that 6.023 into 10 to the power 23 is named as Avogadro's number.
Excuse me, sir. Sir.
So now what we can write? We can write here 6.023 into 10 to the power 23 number of particles. Okay, I'll write here atoms, molecules, or ions of a substance is called 1 mole. Suppose in a place we have that many number of human beings, we can say it's 1 mole of human. Suppose in your house you have this many number of 1 rupee coin, you will call 1 mole of 1 rupee coin. If it is 5 rupees, you will call it 1 mole of 5 rupees. Okay. Now next, we call it gram atomic mass or gram atom. I'll not write here, or I'll write end. Now, what is the gram atomic mass? Just now we have seen that the AMU is such a small quantity. Till now in this world, nobody could prepare a balance where they can weigh up to 10 to the power minus 24 gram or 10 to the power minus 27 kg. It is not possible. We cannot take the weight of one atom. But we have to carry out our chemical experiment. So what should I say here? I'll say atomic mass expressed in gram is called gram atomic mass. That is, if 1.008 is the mass of one atom of hydrogen, if I write here gram, then we call it gram atomic mass of hydrogen. Or I'll call it 1.008 gram of hydrogen is 1 gram atom of hydrogen. If you have taken here 16 atomic mass of, actually it's 15.999, but we write 16. If 16 is the atomic mass of one oxygen atom, if I put a gram here, then we'll call it gram atomic mass of oxygen, or equal to what? 1 gram atom of oxygen. So don't get confused. See, suppose you went to a sweet shop to buy sweets. Suppose you want to buy dry sweets. Two ways you can buy it. One, by weight. You can go and tell, give me 1 kg. Second, you can buy in numbers. Suppose you bought one piece of sweet, say it weighs 32 gram. So you can say, I bought 32 gram of this sweet. But if you count how many are there, only one, then you can say the same thing in that I have bought one piece of sweet. So now we will again use the same one It is called gram molecular mass. Okay. So gram molecular mass or mole. We call it gram mole. Here you mentioned no gram atoms, you can call it gram. So similarly, I can write molecular masses expressed in gram is called gram molecular mass. Gram molecular mass or gram mole. See, this is oxygen molecule. Oxygen atom is 16 gram. Oxygen molecule contains 2 atoms of oxygen, so 16 into 2, 32. Okay. So if you write 32 gram, then you will call it gram molecular mass of oxygen. So what is the gram molecular mass of oxygen? 32 gram. Okay. Or 32 gram is what? 32 gram is the mass of one molecule of oxygen. I can say in any site. I can say one molecule of oxygen weighs 32 gram. So it is a gram molecule. But how many are there? Only one. So I'll call it 1 gram mole. Okay? Okay, gram. We call it 1 gram. So I can write 32 gram of oxygen is gram molecular mass of oxygen equal to 1 gram mole.
আসলে তো ওইখানে কেউ ছিল না ওই টাইমে। তো আমি যখন দাঁড়িয়েছিলাম সাইডে একজন সর্দার ছিল। তুমি জিজ্ঞেস কিসের জন্য তুমি কেন কি সবাই দাঁড়িয়ে আছে ভ্যাকসিন? আমি বললাম জাস্ট আমার জানা ইচ্ছে। তো বলেছে না আমি আমার ভ্যাকসিনের জন্য এসেছি। কনসিস্টেন্ট সার্টিফিকেটটা আছে। আচ্ছা কালকে করতে হবে মানডে টু ফ্রাইডে।
আচ্ছা কালকে করে নেবে তো একটু তাড়াতাড়ি উঠে যাবে। কাল করবে করে কি বলে আর ওই আধার কার্ড নিতে হবে আমি জিজ্ঞেস করেছি তো আধার কার্ড নিতে হবে আর তোমার প্রথম ভ্যাকসিন সার্টিফিকেট। Okay, now see, one more is there. I think 7. Gram molecular masses of any gaseous compound or vapor at normal temperature and pressure. In short form, we call it NTP. Or standard temperature and
So I had one question.
wait, just let me finish. Pressure, we call it STP. What is this? Okay, I'll tell you later on. Pressure occupies 22.4 liter or 22,400 ml or cc of volume. Yes, tell me.
So what's the difference between NTP and STP?
Oh yes, there is a difference is there. Difference is not with the temperature. Temperature in both the cases is 273.15 Kelvin, but the in case of normal pressure is 1 atmospheric pressure equal to 76 centimeter of mercury or 760 millimeter of mercury. But when you go to standard temperature and pressure, the pressure is measured in bar, 1 bar, and it is found 1 bar is slightly less than 1 atmospheric pressure.
Okay, sir. Thank you.
Okay. Now this is called molar volume. তুমি খাবে তো হ্যাঁ মাকে ডেকে দিই না মা তো বললো আমাকে ওরা মা চিৎকার দিবে তারপর মা উঠুক না উঠবে Okay, so now let me summarize. Okay, now see.
ন্যাচারাল জাম বলে না সব মানে কটেজেস বানায় ওটা আনছি
See,
ওটা খালি প্রিজারভেটিভ দেয় না
atomic mass in gram is called what? Gram atomic mass equal to what? 1 gram atom. How many particles is going to have? Is going to have 6.023 into 10 to the power 23 number of atoms. Okay. Now it may happen that it is in the vapor state or gaseous state. Take the example, only the atom which exists in gaseous state, it is the noble gases. That is helium, neon, argon, xenon, krypton, xenon, radon. So if it is in vapor state, then it is going to have 22.4 liter or 22,004 ml at Ntp or Sp. Okay, now I'll go for this next one. Molecular mass in gram. What do you call it? Gram molecular mass or okay equal to 1 gram mole. Okay. So it is going to contain what? 6.02 into 10 to the power 23 number of molecules. Okay. So it is 22.4 liter or 22,004 ml at Ntp or Stp. See, this is a unique thing. Why it is unique? No other rule in this physics and chemistry find a relationship between mass and volume. Mass and volume. So let us do on numerical. how many molecules and atoms of oxygen is present in 8 gram of oxygen. Okay. So now we'll do. See here. Molecular mass of O2 is 32 gram mole inverse. See, why do you write mole inverse? Because it is per mole. All right. So now you know. See here. This is 1 gram mole because of that. See, mole inverse. And each gram mole contains how many particles? This. So we can write 32 gram of oxygen contains 6.023 into 10 to the power 23 number of O2 molecules. So one will come in how much? 6.023 into 10 to the power 23 divided by 32. So 8 will contain how much? It will be 6.023 10 to the power 23 into 8 divided by 32. So it is how much it comes? 4. So 6.023 into 10 to the power 23 divided by 4 will be how much? So it comes to 1.506 into 10 to the power 23. All right. See now, this is number of O2 molecules. Okay, now see, very interesting thing. What does it say? Atoms. What is the atomicity? See, we know each oxygen molecules contain 2 atoms. So what should we write now? Therefore, number of oxygen atoms will be how much? 2 into 1.506 into 10 to the power 23. So how much it will come? It is 12. This will be 0 and this will be 3. So it will be this number of oxygen atoms. Oh. So in the next week we'll do some more problem.